Hi friends, welcome back to Parnika tutorials. In the last video, I have discussed various operators in JavaScript like arithmetic operators, assignment operator, relational operator, logical operators, ternary operator, type of operator and instance of operator. I hope you have watched that video. If you did not watch that video or if you don't know that concept, I request you to go back and watch that video and come back to this video. In this video, I want to discuss about the Bitwise operators in detail. Like I will discuss about the Bitwise AND, Bitwise OR, Bitwise NOT, Bitwise exclusive OR, left shift and right shift. So I sincerely request everyone to watch the complete video for better understanding. Usually JavaScript stores the numbers in 64-bit floating point numbers. So if you give any number, suppose let's consider that I'm giving where a is equal to 5. Now where is a keyword which is useful to define a variable, and then you are writing a which is a variable, and you are using the assignment operator and assigning an integer literal. This integer literal 5 will be stored in 64-bit number, and then if you are converting any bitwise operations, the JavaScript will convert the 64-bit number to a 32-bit binary numbers. This 5 will be converted into a binary form. If I take the 5 and if I'm converting into a binary number, then it will be 101. Now how many bits are there? 3 bits are there. Remaining 29 bits will be assigned 0 because it is a positive 5. So the sign bit also will be a 0. So you will have 29 zeros and then you will have 101. So generally it will store a number in the 64-bit floating point number. Whenever you are performing any bitwise operations, the 64-bit number will be converted into a 32-bit binary number. Then you will perform the bitwise operations like Bitwise AND, Bitwise OR, Bitwise NOT, and then the number which is there in the 32-bit number will be converted into a 64-bit number. Let me discuss with a simple example. As I said earlier, we have the various bitwise operations. Like if you consider one of the bitwise operation is Bitwise AND. Now if I say Bitwise AND between the A is equal to 5 and B is equal to 4, then in that case what will happen? The 5 will be converted into a binary number which is 101. I am not converting into 32-bit. Just for your understanding, I am converting into a 3-bit number. So 5 has been converted into a binary number. Similarly, if you are converting the 4 into a binary number, it will be 101. And if you are saying I am performing the bitwise AND, the bitwise AND operation, what it will do is that it will perform bit by bit. And as it is an AND, if both the inputs are ones, if both the inputs are ones, then only the output will be 1. In all the remaining scenarios, the output will be 0. Now if you consider here you have 1 and 0. As I said earlier, if both the inputs are 1, then only the bitwise AND will give the output as 1. Otherwise it will give the 0 for you. So 1 0 it will give 0, 0 0 it will give 0, and then 1 1 it will give the output as 1 for you. Now this is a binary number. This binary number again will be converted into a 64-bit floating point number, or I can say it will be converted into a decimal number. If you are converting the 100 into decimal number, you will get the output as 4. So you are giving the 64-bit floating point number. That 64-bit floating point number will be converted into binary number, and then bitwise operation will be performed, and the resultant binary number will be converted into again 64-bit floating point number or a decimal number, and then it will display the output for you. So this is the internal operations will be happening in the all the bitwise operations. Let me discuss in detail about the bitwise AND operator. You can ask me, sir, already you have discussed about the bitwise AND operation, but I will discuss how this 5 has been converted into a binary number 101, and then I will discuss how this 100 has been converted into a decimal number 4. All these things I will discuss so that it will be very clear for you. Let me go to this PPT and then I will make it into the full screen, and then I will discuss how can you convert any decimal number to the binary number and then binary number to decimal number. Then it will be clear for you. Let's consider that I have taken a decimal number 5, which is, I can say, base 10 number, and now I want to convert into a binary number which is a base 2 number. How I need to convert is, I need to take the decimal number 5 and then I need to divide by 2. You can ask me why we need to divide by 2. If you consider any binary number which is in the form of ones and zeros, so if you take any binary number, it will have either 1 or 0, means combinations of ones and zeros only will be there. Now any decimal number, if you want the remainders ones and zeros only, then you need to divide by 2. If you divide by 3, you will get the remainder 0, remainder 1, remainder 2 also. But in the binary number, you will not have the remainder 2. So that's why you need to divide the decimal number by 2. Now whenever you are dividing any number by other number, you will get the two components. One is the quotient and another one is the remainder. Look at here. If I divide 5 by 2, I will get the quotient as 2. So you need to keep the quotient here and the remainder here. And again 2 is equal to 2. So you need to again divide the 2 by 2. So if you divide, you will get the quotient as 1, remainder as 0. Now if you look at 1 is less than 2, I can stop the division process. Then you will have 1, 0, 1. This 1 I will consider as a MSB, which is most significant bit. This one I will consider as a LSB, which is least significant bit. Always whenever we represent any number, we will represent MSB and then LSB. So you will have this 1, you need to consider as a MSB, 0, 1. So you need to take from bottom to the top. So that's why you got the 5 in the binary form as 101. Similarly, if I consider 4, that 4, if I am converting into binary number, I need to divide by 2. So if I divide 4 by 2, I will get the quotient as 2, remainder as 0. Again, if I divide by 2, I will get the quotient as 1, remainder as 0. Now this 1 I will consider as a MSB and this 0 I will consider as LSB. So I will get 1, 0, 0. Now if I am performing the bitwise AND them, then what will happen? As I said earlier, if both the inputs are 1, then only the bitwise AND will give the output as 1. In all the remaining cases, it will give the output as 0 for you. So this is very important. Now you look at 1 and 0. 1 and 0 means you will get 0. 0 and 0, bitwise AND will give 0. Then 1 and 1, it will give the 1 for you. Now you got the binary number 100. This 100, you need to convert into a decimal number. How can we convert 100 to a decimal number is, you need to take 100. Now this binary number I want to convert into a decimal number. How I need to do? For every digit you will have the weight. Now LSB will have the weight 2 to the power 0. This one will have the weight 2 to the power 1. This one will have the weight 2 to the power 2. So you need to multiply the each digit with its weight and then you need to do the summation. Then it will be 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2. 0 multiply with anything will be 0. Plus 0 multiply with anything will be 0. 1 into 2 to the power 2, which is 1 into 4, you will get 4. So 0 plus 4 will give the decimal number 4 for you. So you will get the output as 4. So now let me discuss this concept practically with an example so that it will be clear for you. Let me go to the desktop, Visual Studio, and then let me write the program. I will write where a is equal to 5, where b is equal to 4, and then I will write console.log a bitwise and b. So this is the symbol or the notation to represent the bitwise and. Now let me save this program and execute it. See, as I said earlier, we got the output as 4. Let me give it as 15 and then 4. Let's see what will happen if I consider 15 and 4. First, I need to convert the 15 into binary number. If I am converting 15 into binary number, let me see how it will work. I need to divide the 15 by 2. If I divide, I'll get the quotient as 7, remainder as 1. And then again I need to divide 7 by 2. I will get the quotient as 3, remainder as 1. Again I need to divide 3 by 2. I will get the quotient 1 and remainder 1. So this one will be MSB and this one will be LSB. So you need to represent it as 1111 in the binary form for the 15. Now 4. How I need to consider 4? Just now we have discussed 4. You need to divide by 2. You will get the quotient as 2, remainder as 0. Again if you divide by 2, you will get the quotient as 1, remainder as 0. So it is 1, 0, 0. And this bit you need to consider as 0. Now if you are performing the bitwise AND, 1 and 0 you will get 0. 1 and 0 you will get 0. 1 and 1 you will get 1. 1 and 0 you will get 0. Now 0, 1, 0, 0. If you are converting into a decimal number, you will get 4. How you can verify it? This one weight is 2 to the power 0, this one weight 2 to the power 1, this one weight 2 to the power 2, this one weight 2 to the power 3. Now everything if you multiply with 0, you will get 0 only. So 0 into 2 to the power 0 will be 0. 0 into 2 to the power 1 is 0. 1 into 2 to the power 2 will be 4. 0 into 2 to the power 3, 0. So you will get 4 only. If you want to verify, let me execute this program. Let me save this one and execute it for you. See, we got the output as 4. Now 15 and 14, if I perform the bitwise AND, what will be the output? You can please note it down or you can write the answer in the comment section. Now 15 is 4 ones, 14 means I will have 1, 1, 1, 0. So if I am performing the bitwise AND between these two numbers, I will get 0, 1, 1, 1. So if I am converting that into a decimal number, I will get the output as 14. If you want to verify, let me save it and execute this program. As I said earlier, we got the output as 14 for you. I hope you have understood how the bitwise AND operation is working. Now let me discuss about the bitwise OR. The bitwise OR, if any of the input is 1, then it will give the output for you. Let me draw the truth table of the bitwise OR. Okay, let me insert a table and then I will take A, B and then A bitwise OR B. So this is the symbol or the notation to represent the bitwise OR. You will have 0 and 0. If you take both the inputs as 0, the bitwise OR will give the output as 0 for you. If you are giving 0 and then 1, then you will get the output as 1. If any one of the input is 1, the bitwise OR will give the output as 1 for you. So 1, 0 will give 1, 1 and 1 will give the output as 1 for you. If you want to verify, look at this one. A is equal to 5, B is equal to 4, and if I am performing the bitwise OR, the 5 if I convert into a binary number, I will get 1, 0, 1. 4 if I am converting into binary number, I will get 1, 0, 0. Now if I am performing the bitwise OR 1, 0, what you will get? 1, and then 0 0 you will get 0, 1 and 1 you will get 1. That 101 is a binary number. If you're converting back to a decimal number, you will get 5. If you want to verify, let me execute this one in the Visual Studio. I will write A is equal to 5, B is equal to 4. In place of bitwise AND, let me use the bitwise OR. Let me save this program and execute it for you. Okay, as I said earlier, we got the output as 5. Till now we have discussed about the bitwise AND. The notation to represent the bitwise AND is, we have used this notation. So this is the notation for representing the bitwise AND, and then we have discussed about the bitwise OR. This is the notation or the symbol to represent the bitwise OR, and then we have bitwise exclusive OR or XOR. The notation or the symbol for representing the bitwise exclusive OR, this is the symbol. And then we have the bitwise NOT. We need to use this notation for representing the bitwise NOT, and then we have the left shift and right shift. You will have A, left shift B. On A, you are performing left shift B number of times. Similarly, we have right shift. The right shift will be represented like this. You will have A, right shift operator B. Then on A, you are performing B number of times right shift. Now let me discuss about the exclusive OR. Let me first discuss about the truth table of exclusive OR, and then I will discuss how we will get this truth table. If both the inputs are same, then it will give the output as 0 for you. So you have 0 and 0. As both the inputs are same, it will give the output as 0 for you. Similarly, 1 and 1, as both the inputs are same, it will also give the output as 0 for you. If the inputs are different, look at here, 0 and 1, both the inputs are different, so you will get the output as 1 for you. Similarly, 1 and 0, you will get the 1. So you can remember simply like, if both the inputs are same, then you will get the bitwise exclusive OR as 0. If both the inputs are different, the bitwise exclusive OR will give the output as 1 for you. Okay, now let me discuss how you will get this truth table. If both the inputs are 0, how you will get the output as 0. If both the inputs are different, how you will get the output as 1. Let me discuss it for you. Let me erase everything which is there in this slide, and then I will write A exclusive OR B. Then if I expand this one, it will be A bitwise AND or the logical AND, B's complement, and then logical OR, A's complement and B. Now if I take A value as 0 and B value as 0, then 0. Okay, you have bitwise AND, and then you have the 0's complement, and then 0's complement, and then you have the 0. 0 complement you will get 1, and then 0 complement you will get 1 and 0. 0 and 1 will give the 0. 1 and 0 you will get 0. 0 or 0 you will get 0. So if you take both the inputs are same, even you can take 1 and 1. If you take 1 and 1, substitute A value as 1 and B value as 1. So you will have A which is 1 and B also 1. So 1 and 1's complement, or 1's complement and 1. So 1's complement is what? 0. So it is like NOT. NOT of 0 is 1. NOT of 1 is 0. And then you will get 0 and 1. 1 and 0 you will get 0. 0 and 1 you will get 0. 0 or 0 you will get 0. So if both the inputs are same, the exclusive OR will give the 0 for you. Let me discuss if both the inputs are different, how it will work. Let me consider A value as 0, B value is 1. Then let me substitute it. What is the expansion? A and B's complement, or A's complement and B. Then let me substitute A value is 0, B value is 1. Then 0 and 1's complement. 1's complement means what? You will get 0. Not of 0, you will get 1 and 1. 0 and 0, 0. 1 and 1, 1. 0 or 1 means 1. So you will get the finally output as 1. So this is the reason behind getting that truth table for you. I hope you have understood about the exclusive OR. Let me discuss with a simple example. A value is equal to 5, B value is equal to 4. Between them, if I am performing the exclusive OR, then how it will work, let me discuss. So 5 you need to convert into a binary number, you will get 101. 4 if you are converting to binary number, you will get 100. Now between these two numbers I need to perform the exclusive OR. Now both the inputs are different, so you will get the output as 1. Both the inputs are same, you will get 0. Again both the inputs are same, you will get the 0. Now 001 is a binary number. If you are converting into a decimal number, you will get the output as 1. How you will get? 001. So you need to take the weights 2 to the power 0, 2 to the power 1 and 2 to the power 2. So which is nothing but 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2. So 1 into 2 to the power 0 means what? Anything power 0 is 1. So 1 into 1, 0 multiplied with anything will be 0. So 1 into 1 means 1. 1 plus 0 you will get finally 1. So this is the way the exclusive OR will work. If you want to verify, let me write a program and discuss it with you all. A value is equal to 5, B value is equal to 4, and I am writing console.log A exclusive OR B. Let me save this program and execute it. See, as I said earlier, we got the output as 1. Let me take A value is equal to 15 and B value is equal to 14. Now can you please tell me what will be the exclusive OR for between this 15 and 14? If you know the answer, please write it in the comment section. Now let me discuss it if you does not know. A having the value 15, the 15 if you are converting into binary number, you will get 4 ones, and 14 if you are converting into binary number, you will get 110. Now if you are performing exclusive OR between 1 and 0. Now both the inputs are different, so you'll get the output as 1. Now 1 and 1 both the inputs are same, you'll get 0. Again 1 and 1 both the inputs are same, you'll get 0. 1 and 1 both the inputs are same, you'll get 0. So 0 0 0 1, that if you're converting into a decimal number, you will get 1. Now let me save this program and execute it. As I said earlier, you got the output as 1. So like this we can perform the exclusive OR in the JavaScript, which is a bitwise exclusive OR. Now let me discuss about the bitwise NOT operation. If you need to understand the bitwise NOT, you need the 2's complement representation. In any programming language, generally we will have the sign magnitude representation, 1's complement representation and 2's complement representation. But generally the negative numbers will be stored in the 2's complement representation only. For understanding, let me discuss about the sign magnitude representation, 1's complement representation and 2's complement representation. When I am discussing about the sign magnitude representation and 1's complement representation, I will discuss the demerits of it and how those demerits have been overcome in the 2's complement representation also. Let me discuss it with you all. Let me discard this one and then let me make it full screen from the current slide. Now let me use the pen. So as I said earlier, we have the sign magnitude representation, 1's complement representation and 2's complement representation. Now let me discuss about the sign magnitude representation. if I want to represent plus 5. Now, till now we have said a is equal to 5, b is equal to 4. As we did not set the sign for it, by default it will be considered as a positive number. Suppose in mathematics if I write 5, then what I can say it is a positive number. If I want to represent a negative number, then I will write minus sign in between before that one. So then it will be a minus 5. Similarly, if you are storing the negative numbers, the representation will be different. For a positive numbers, the representation will be different. Now, if you are representing the plus 5 in the binary format, you will have the sign bit. If the sign bit is 0, then you can say the given number is a positive number. If the sign bit is 1, you can consider that the given number is a negative number. So sign bit will have either 0 or 1. If you have the sign bit as 0, then you can say the given number is a positive number. If the sign bit is 1, you can say the given number is a negative number. So let me discuss how can you represent plus 5 and minus 5 using the sign magnitude representation. First you will represent 5, okay, in binary form. If you represent the 5 in the binary form, you will have 1, 0, 1, and then we will have the sign bit. As the given number is a positive number, the sign bit will have the value 0. Similarly, if you are representing minus 5, first you will represent 5 in the binary form, you will have 1, 0, 1. And as I said earlier, the sign bit should be 1 for the negative number. So this is the way you can represent the positive number and the negative number. Then you can ask me, sir, the process is very simple. For a positive number, first I will convert the number into binary form and the sign bit I will keep it as 0. If it is a negative number, first the number will be converted into binary number. For the negative, I will keep the sign bit as 1. The process is very simple. Then why we are not using the sign magnitude representation to store the negative numbers in the memory? Let me discuss it. First we will consider plus 0. Now let me consider the 0 into 3-bit binary number, and sign bit, as it is a positive 0, the sign bit will be 0. Similarly, I will take minus 0. If I am converting to binary number, let's consider that I got 3 zeros, and the sign bit, as it is a negative number, I will keep 1. Then you can ask me, sir, in mathematics, plus 0 and minus 0 same, because if I take 5 plus 0, I will get 5. 5 minus 0 also I will get 5. So whether it is a plus 0 or minus 0, we need to consider them as a 0 only. Now if I need to store the 0, should I use this representation or this representation? There is a confusion. For plus 0 we have one representation, for minus 0 you have another representation. So it leads to the confusion. So that's why people are not practically using the sign magnitude representation. This is the demerit. Now let me discuss about the ones complement representation. If you want to understand the ones complement representation, you need to understand how to find the ones complement for a binary number. Now, if you have the input as 1, the ones complement of 1 will be 0. If you have 0, the output will be 1. So, you have the input 0, then it will give the output as 0. If the input is 0, the output will be 1. Now, let me consider 1, 0, 1, 0, 0. For this binary number, if I want to compute the ones complement, 0 will be converted into 1 and 1s will be converted into 0. So, this is the resultant ones complement for the given binary number. Like this, you can compute the ones complement for a binary number. Now let me discuss about the ones complement representation. Remember one important point. For a positive numbers, the representation will be same either in the sign magnitude representation, ones complement representation and twos complement representation. Only for the negative numbers, the sign magnitude representation, ones complement representation and twos complement representation will vary. Now let me discuss how can you represent minus 5 in ones complement representation. If you want to represent a minus 5 in ones complement representation, first you need to find the representation for its positive number. The positive number will be plus 5. First plus 5 what you will do, again you will convert the 5 into binary number. You will get 101, and then the sign bit, as it is a positive number, you will get 0. So for plus 5 you got 0101. Now if you want to represent minus 5 in ones complement representation, you need to find the ones complement of plus 5. What is the plus 5? 0, 1, 0, 1. For this one, you need to find the ones complement. Then you will get 1, 0, 1, 0. So 1, 0, 1, 0 is a ones complement representation for minus 5. So like this, you can find the ones complement representation for a negative number. Let me consider minus 10. Okay, first what I need to do, I need to represent plus 10. 10, what I need to do, I need to convert into a binary number. Then I will get 1, 0, 1, 0, and then I need to keep plus sign. So sign bit will be 0. Now I need to find the minus 10. What I need to do, I need to find the ones complement of this given plus 10. Then you will get 1, 0, 1, 0, 1. So 1, 0, 1, 0, 1 will be the representation for the minus 10 in ones complement representation. Now you can see sign bit is 1. So I can say it is a negative number. Now you can ask me, sir, the difference between ones complement representation and sign magnitude is, suppose look at here, minus 10, if I am representing in the sign magnitude representation, first I will represent 10, 1, 0, 1, 0, and then I will keep 1. Now this minus 10 is in representation of sign magnitude, and this is in ones complementation. Now both are different. So as I said earlier, for positive numbers, the sign magnitude representation, ones complement representation, and twos complement representation is same. For the negative numbers, it will vary. Now let me discuss the issue with the ones complement representation. Let me represent plus 0 and minus 0 in ones complement representation. So 0, if I am converting binary number of 3 bits, it will be 0, 0, 0, and as it is a positive 0, the sign bit will be 0. Now if I want to represent minus 0 in ones complement representation, I need to find the ones complement of plus 0. It will be all ones. Now plus 0 and minus 0 is 0, but you have two different representations in the ones complement representation. That's why we are not practically using ones complement representation to store the numbers in the memory. Now let me discuss about the twos complement representation. If you want to understand the twos complement representation, you need to know how can you find the twos complement of a given binary number. Okay, suppose let's take that 100 is the given binary number. For this binary number, if you want to convert into twos complement form, or you want to find the twos complement of the given binary number, then what you are supposed to do is that you need to first find the ones complement of it and then add 1 in the LSB. So you have 1000 is a binary number. For this one, if you want to find the twos complement, first you need to find the ones complement. It will be 0, 1, 1, 1. How you got it? If the input is 1, the output will be 0. If the input is 0, the output will be 1. So 1, 0, 0, 0, you got the ones complement as 0, 1, 1, 1. Now, if you want to find the twos complement, you need to add 1 into the LSB. Now 1 and 1 plus 1, which is a bitwise. So you should not get 2. Okay, instead of that 1, you will get the sum as 0, carry as 1. Then 1 plus 1. Again, you will get sum as 0, carry as 1. Now 1 plus 1, you will get sum as 0, carry as 1, and finally you will get 1. So this is the twos complement for the given number. Now for this number, the original number and twos complement both are same. Let me discuss one more example. Let's take 1, 0, 0, 1, 0. Okay, now for this number, if I am finding the twos complement, first I need to find the ones complement. It will be 0, 0, 1, 0, 1. and then I need to add 1 to the LSB. Okay, now lot of people may not aware how the addition will happen. If you have A, B, you will have the sum and carry. Whenever you are performing the addition, you will get the sum and carry. If both the inputs are 0 and 0 1 1 0 1 1, we'll discuss all this scenario. 0 plus 0, the sum will be 0 and carry also 0. 0 plus 1, the sum will be 1, carry will be 0. 1 plus 0, the sum will be 1 and carry will be 0. 1 plus 1, the sum will be 0 and carry will be 1. So this is the truth table of half adder. Now using this truth table, you can perform the addition. Now look at here, 1 plus 1, then the sum will be 0, carry will be 1. 0 plus 1, the sum will be 1, carry will be 0. 1 plus 0, the sum will be 1, carry will be 0. 0 plus 0, the sum will be 0, carry also will be 0. 0 plus 0, the sum will be 0, and carry is 0, you can neglect it. So you got 0 0 1 1 0. So this is the 2's complement for the given binary number. So like this you can find the 2's complement. Now let me discuss how can you represent a positive number and a negative number in the 2's complement representation. As I said earlier, if it is a positive number, the sign magnitude representation, 1's complement representation and 2's complement representation will be same. Only it will vary for the negative numbers. Now if I want to represent minus 5 in the 2's complement representation, first I need to represent plus 5. So how I'll represent plus 5? 5 I will convert into binary number. I'll get 1 0 1. For this binary number, what I need to do is that I need to add the sign bit. Okay, as it is a positive number, the sign bit will be 0. Now if I want to find minus 5 in the 2's complement representation, I need to find the 2's complement for the plus 1. If I find the 2's complement for 0 1 0 1, first I need to find 1's complement. The 1's complement will be 1 0 1 0. For this one you need to add 1, you will get 1 0 1 1. So minus 5 will be 1 0 1 1 in 2's complement representation. So if they ask you to represent a negative number in 2's complement representation, first you will represent the positive number. For the positive number, you will find the 2's complement and then you will represent it. Okay, so like this we will represent the 2's complement representation. Earlier in the sign magnitude representation and 1's complement representation, for the plus 0 and minus 0 we have two different representation. That is the demerit of it. Now let me discuss how this demerit has been resolved in the 2's complement representation. If I want to represent plus 0, let me convert the 0 into 3-bit binary number. So I'll have 3 zeros and sign bit will be a 0. Okay, now you have minus 0. Minus 0 means what you need to do, you need to find the 2's complement of it. How you can find the 2's complement? For the all the zeros, you need to find the 1's complement. You will get all 1's and then you need to add 1 in the LSB. 1 plus 1, the sum will be 0 and the end carry will be 1. 1 plus 1, sum will be 0, carry will be 1. 1 plus 1, the sum will be 0, carry will be 1. 1 plus 1, sum will be 0 and the end carry 1, you can neglect it. So you again got all zeros. So plus 0 and minus 0, you have the same representation. So that's why there is no confusion to represent the plus 0 and minus 0 in 2's complement representation. So that's why practically we will use the 2's complement representation to store the negative numbers. Then you can ask me, sir, for discussing about the bitwise NOT, why you have represented this or why you have discussed about this sign magnitude representation, 1's complement representation and 2's complement representation. There is a reason behind it. Let me discuss it with you all. Okay, let's consider that a value is equal to 5 and now you want to perform the bitwise NOT. How it internally works, let me discuss it for you. First, you have the 5. 5 you need to represent in the binary form. As it is a positive 5, you will have 101 is a binary form and the sign bit will be 0. Now the bitwise NOT is very simple. It works in the same way as 1's complement. Meaning is that if the input is 1, output will be 0. If input is 0, output will be 1. This is the bitwise NOT. So what they are saying, you need to find the bitwise NOT of A. So the A having the value 5, as it is a positive 5, you are representing as 0101. Now for this 0101, you need to find the bitwise NOT. So whenever you have the input 1, you should get the output as 0. Whenever you have the input 0, you should get the output as 1. So you will get 1010. Now, lot of people will say that this number you need to convert into decimal number and you will say this is the result. That is absolutely wrong. Now, you look at the sign bit. The sign bit is 1. Now, what is the meaning sign bit is 1 means it is a negative number. And I told you earlier that negative numbers in computer will be stored in 2's complement representation. So, this number now is in the 2's complement. Now, you need to convert into the binary number and then binary number you need to convert into decimal number. As you have 1010, you will say that the resultant will be a negative number. Now, you need to convert into binary number. So, for the given number, you need to convert into again 2's complement form. Okay. So, if you find the 2's complement for 1010, what will be? First, you need to find the 1's complement. So, you will get 0101 and then you need to add the 1 for it. So, you will get 1 and 1, sum will be 0, carry will be 1. So, you will get 0110. So, 0110, if you are converting into a decimal number, you will get the 6. So, you can say resultant will be minus 6. Let me discuss again for you. They have given the A value is equal to 5 and they asked you to perform the bitwise NOT. The first 5 you need to represent in the binary form and for that number you need to find the bitwise NOT. Now, you have identified that sign bit is 1. So, I can say it is a negative number and the negative number will be represented in the 2's complement form. So, what you are supposed to do is that you need to convert the 2's complement form into the binary number. If you want to convert it again for that number, you need to find the 2's complement and then you need to keep the value. If you want to verify practically, let me discuss with a simple example. I am considering where A is equal to 5 and if I write console.log and then you can say bitwise NOT A. Now, let me save this program and execute it for you. You got the output as minus 6. Then you can ask me, sir, in return test or any place if they ask, shall I need to do this entire process? No. The shortcut is if A is having the value n and if they are asking you to find the bitwise NOT for the A, then you can say minus of n plus 1. In this question, the A value is having the value 5. So, n is 5. So, minus of 5 plus 1 will be 6. So, you will get minus 6. If you want to verify, let me keep 15 here. Then, bitwise NOT of 15, you will get output as minus 16. If you want to verify, let me execute this program. As I said earlier, we got the output as minus 16. So, n value is equal to 15. 15 plus 1 will be 16. So, minus 16 you will get. Now, let me discuss if I keep minus 15. For minus 15, if I am performing the bitwise NOT, what will happen? Let me discuss it for you. We have discussed for the positive numbers, how can we find the bitwise NOT. For the negative numbers, let me discuss. So, the given number is a negative number. So, negative number, how you will store in the memory? In the 2's complement form. First, you need to represent the minus 15 in the 2's complement form. So, what you will do? First, you will represent plus 15. For plus 15, you will find the 2's complement. Now, 15 you will have 1, 1, 1 and it is a plus 15. So, sign bit will be 0. So, you have 0, 1, 1, 1, 1. Now, for this one you need to find the 2's complement. Okay, if you find the 2's complement, let me write it directly. You can find 1's complement and add 1, but I'll use the shortcut. So I'll keep the 1 as it is and the remaining bit the 1's complement. So I'll get 1 0 0 0. So this is the minus 15, or for the 0 1 1 1 1, 2's complement will be 1 0 0 1. So minus 15, you are representing it as 1 0 0 1. For this minus 15, you need to find the bitwise NOT. What will be the bitwise NOT? If you have the input as 1, output will be 0. Input is 0 means output will be 1. So you will get 0 0 1 0. Now what is the sign bit? 0. So you can say that given number or the output, you got it as a positive number. As it is a positive number, it can be directly converted into a binary number, because for the positive numbers, the representation for the sign bit, 1's complement representation and 2's complement representation will be same. So you got 1 1 1 0. 1 1 1 0 means you will get 14 if you convert into decimal number. So if the given number is minus number, which is minus 15, the bitwise NOT you will get plus 14. If you want to verify, let me discuss with a simple example where a is equal to minus 15 and console.log bitwise NOT a, you will get the output as plus 14. So what is the shortcut for it? If you have a is equal to minus n, then simply you neglect the minus symbol. For that number, you need to find n minus 1. So here a value having minus 15. So n you consider as 15. 15 minus 1 means 14. If you want to verify, let me discuss for one more example. Let me consider a value is equal to minus 5. Bitwise NOT of minus a means you will get plus 4. If you want to verify, let me execute this program. As I said earlier, we got the output as 4. So we have discussed about the bitwise AND, bitwise OR, bitwise NOT and bitwise exclusive OR. Now let me discuss about the left shift. How you will represent the left shift? A, left shift operator B. What is the meaning? On A, you need to perform left shift by B times. Now let's consider that you have 5. You want to perform left shift by 1 time. So this is the representation for representing left shift operation. Then how it will work, let me discuss it for you. So A is having the value plus 5. The plus 5, if you represent it, you will get 1 0 1 and sign bit will be 0. Now if you perform left shift by 1, then one time you need to perform the left shift. If you perform the left shift, what will happen? Let me discuss it with you all. So this 1 will be left shifted to here. This 0 will be left shifted. This 1 will be left shifted. This 0 will be left shifted. And this empty place, you will get 0. So 0 1 0 1, if you perform left shift by 1, you will get 0 1 0 1 0. Now you need to find the decimal number for it. So what will be it? The weight will be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So you will get 0 into 2 to the power 0, 1 into 2 to the power 1, 0 into 2 to the power 2, 1 into 2 to the power 3 plus 0 into 2 to the power 4. 0 multiplied with anything will be 0, 1 into 2 to the power 1 will be 2, then 0 multiplied with anything will be 0, 1 into 2 cube will be 8, 0 multiplied with anything will be 0. So 2 plus 8 you will get 10. So the 5 left shift by 1 means you will get the output as 10 for you. Okay, if you want to verify, let me discuss with an example. A, I am taking it as 5 and B value I am taking it as 1. So I am left shifting A by B number of times. So the representation will be A left shift operator B. So if I execute this program, we'll get the output as 10. Let me consider 15. 15, if I am performing the left shift by 1, you will get the output as 30. If you want to verify, look at here. We got 30. If I write B value is equal to 2, meaning is that 15 you need to left shift 2 times. Then you will get the output as 16. 60. If you want to verify, you got the output as 60. Let me discuss how you got the output as 60. So let me consider A value is equal to 15, B value is equal to 2. So 15 I need to perform left shift by 2 bits. So first 15 I need to convert into a decimal number. I will get 1111 and sign bit will be 0. Now 15 left shift 2 times. First let me perform 1 time. So I have 0 1 1 1. I need to perform the left shift. Let me consider all the bits. So this one will come here, 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 and this 0 will come here. In this empty place you will get a 0. So one time if you left shift, you got this one. Now let me perform left shift one more time. So you will have 0 here. You can keep all the, so 0 will come here, 1 will come here, 1 1 1 0 0. So you have 0 1 1 1 1 0 0. So if you convert into decimal number, the weights will be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. So if you convert into decimal number, you need to multiply the digit with the weight. So 0 into 2 to the power 0 plus 0 into 2 to the power 1, 1 into 2 to the power 2. Let me write here 0 into 2 to the power 0, 0 into 2 to the power 1, 1 into 2 to the power 2, plus 1 into 2 to the power 3, plus 1 into 2 to the power 4, plus 1 into 2 to the power 5, plus 0 into 2 to the power 6. 0 multiply with anything will be 0. So 0 into 2 to the power 0, 0, 0 into 2 to the power 1 is 0, 1 into 2 to the power 2 is 4, 1 into 2 cube is 8, 1 into 2 to the power 4 is 16, 1 into 2 to the power 5 is 32, 0 multiply with anything will be 0. So you will have 32 plus 16 which is 48, 48 plus 8 is 56, 56 plus 4 is 60. So you got the output as 60. So you can ask me, sir, how we can directly find the answer? You have A left shift B, then it is nothing but A into 2 to the power B. You have 15 left shift 2 times means A value is 15 and B value is 2. So 15 into 2 to the power 2 is nothing but 15 into 4. You will get the output as 60. So this is the way you will perform the left shift. Let me discuss about the right shift so that it will be clear for you. The representation for right shift is you will have A right shift B. So meaning is that on the A you want to perform right shift by B number of times. Then let's consider that A value is equal to 15 and B value is 1. 15 I want to perform right shift by 1 time. So 15 what I will do? Plus 15, right? So I will convert into binary form for 15, 4 ones I will get and sign bit will be 0. Now I want to perform the right shift. Okay, if I'm performing the right shift, what will happen? This 0 you will get here, this 1 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 you will lose it. Okay, the LSB 1 you will lose it. In the empty place you will get a 0. So you got the output as 0 0 1 1 1. Now if you convert this one into decimal number, you will get the output as 7. Okay, if you want to verify, let me discuss with a simple example. A value is equal to 15, B value I have taken as 1, and then I am performing A right shift by 1. Let me save this 1 and execute it. So you got the output as 7. So like this the right shift will work. Let me discuss one more example. If I am taking 5 and B value I am taking it as 2, then A right shift by B you will get it as 1. How you got the 1? Let me discuss it with you all. So A value is how much? 5. B value is how much? 2, and you are saying A right shift by B. So 5 you need to perform right shift by 2 times. So then how it will work is that 5 if you convert into binary number you will get 1 0 1. As it is a plus 5, the sign bit will be 0. And now you need to perform right shift 2 times. First let me perform right shift 1 time. Okay, this 0 you will get here, this 1 you will get here, this 0, and the LSB 1 you will lose it, and this empty place you will get a 0. So one time if you are performing the right shift, you got 0 0 1 0. Again you need to perform the right shift, because you need to perform right shift 2 times, because b value is 2. Now this 0 you will get here, this 0 you will get here, 1 you will get, this 0 you will lose, and the empty place you need to keep a 0. So LSB is having either 1 or 0. In the empty place you will get a 0. So you got 0 0 0 1. So this binary number, if you convert it into a decimal number, you will get it as 1. Okay, now what is the shortcut is a divided by 2 to the power b. So a value is 5, divided by 4 means you will get the quotient as 1. So like this the right shift will work for you. I hope you have understood about all the bitwise operators such as bitwise AND, bitwise OR, bitwise exclusive OR, bitwise NOT, left shift and right shift. If you still have any doubts related to the bitwise operators, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.